My talk was on predictive prefetching. My name is Divya Tagtachian, as Katie mentioned. I go by short div online, so feel free to tweet at me. If you like this presentation, or if you have questions, or if you want to talk about climbing, I'm happy to talk through that. I work at Netlify, which is a static site deployment platform, and I work specifically on the developer experience team with Phil Hawksworth, actually, who gave a talk yesterday on boring is better or something like that. And I've been working at Netlify for about 2 years, so that's really exciting. And throughout the entire time, I've been working remotely from my apartment in Chicago. So during this time, nothing much has changed, except that I don't go outside anymore. Also, one other thing that has changed is I order a lot of takeout now because the prospect of ordering or going out to get groceries and cooking and cleaning is just too much work. And as Katie mentioned, I have better things to do, like building a climbing wall in my apartment. But one of the things I noticed from ordering a lot of takeout is the general trends of what I eat. So I don't know if this is just a indication of my growing palate or the fact that I'm becoming more American, but I've been ordering a lot of fries. And when you order fries, at least in the US, it generally comes with 2 condiments. It comes with mayo and it comes with ketchup. Oftentimes ketchup, sometimes mayo, sometimes both, it depends. And so the thing is, you don't necessarily ask for those condiments, they just automatically come to you. And the assumption is that the average American eats fries with ketchup and mayo. And this is not the case in other parts of the world. For example, I think in the Netherlands, you eat it with other condiments. I can't remember. I think mayo, yes. And so in the US, it's generally ketchup. But the nice thing is that the person packing the takeout order just pre-optimizes. You don't have to ask for it. They just assume that you want ketchup, which is really nice because you don't have to ask for it. Even though you might not like ketchup, it's just something that is there in the event that you want it. So you don't have to reach into your fridge to get ketchup, even though that's easy. You automatically have it for you. And so it leads to an automatically delightful eating experience because you have something that you didn't necessarily ask for, but that you can reach for if you want. And this experience would be really nice if it were replicated in various parts of your life. Let's say if you were to view a website and the website automatically knew which pages you wanted to go to. And that's the whole concept of prefetching, the ability for a browser or a website to know where you're going to go and fetching resources ahead of time on your behalf. So you don't have to ask or you don't have to wait. It just automatically knows. And that's a really nice thing. Before we move much further into prefetching, I'd like to go over the current status of how exactly requests are made and resolved on the web. So we'll walk through that in some detail, not too much detail, but we'll start with the most basic example, which is if you were to request a page. So if you're navigating to a page, either clicking a link, in this particular case, you're just typing it in the address bar. The browser doesn't yet know where the resources associated with that domain name is, so it needs to make a DNS request essentially to the server to get an IP address. And so the server responds with that. And then with this IP address, the browser can then do the TCP TLS dance and establish a connection with the server. And this allows for that data transfer. And so again, it depends on where the server is located. So if you're talking about an origin server, that's a bit further from a user. CDN is a bit closer because that's an edge node. But when you deal with this kind of establishment of connection, this TCP TLS, it takes time. And latency comes into play because that is essentially how data is transferred and how the browser talks to the server and so on. And so that can take anywhere from a couple of milliseconds to a couple of thousand milliseconds, depending on your bandwidth, depending on latency and so on. So that's one aspect of how things can take time when you make a request on the web. The other thing that takes time is also the rendering of the page. So Paul Irish talked a lot about largest contentful paint and everything. This is kind of broad strokes here. But generally, when you want to render, you need to get resources in order to render them. And the first request tends to be the index.html page because that's the most basic level that you need in order to render a page. So the browser goes to ask the server for the index.html page, and then it responds in kind with that particular resource. Of course, we're all web developers, so we know that that's not the only thing you'll need. There's, of course, CSS and JavaScript. So once the index.html is parsed, the browser then goes on to ask for the other pieces of the website that it needs. So the CSS and then the JavaScript following. And of course, in this particular case, it's resource blocking, so it can't make the request at the same time. There are, of course, some optimizations that they can make. But generally speaking, in a broad strokes level, it needs to make those requests one after another, and it needs to wait for those things to happen. So again, that takes time. It can be really slow. Again, browsers have optimizations for this that they can use in order to make this a little faster. So TCP pre-connect is one of them, and so on. But in this particular talk, what we're focusing on isn't the optimizations browsers make on your behalf. It's the particular techniques that we as a developer use and utilize to improve the overall experience of a site so that users see the speed and the performance that they want, that seamless performance that you would expect. And for this, we'll be focusing on three main concepts, which will follow throughout the course of this talk, really. Those are DNS prefetch, link prefetch, and pre-rendering. And so we'll start from the top and work our way down. DNS prefetch is the most basic form of prefetching. It's essentially the establishment of the connection. So the first step in which the browser actually gets resources. So it's before it gets resources when it needs to establish that connection. And so at this level, it's actually the lowest cost because from a bandwidth perspective, you don't need a lot of bandwidth in order to do that. So you don't run into a lot of latency problems at this point because all it's doing is it's establishing that connection for future requests. So that's the most, the lowest level in which you can do prefetching. The next level is link prefetching. So not only are you establishing that connection, you're going one step further and actually grabbing the resources you need. So this can be in the form of like a JavaScript file or a CSS file, whichever you need. And you're prefetching and grabbing those resources ahead of time. So when a user actually navigates to that page, the browser already has resources it needs and it can just render the page automatically. So that reduces the latency that you get or the rendering time overall. Pre-rendering is the next level, and of course it takes both of those earlier concepts to its logical extreme. And as the concept might indicate, pre-rendering pre-renders, so it renders ahead of time. So before a user even navigates, there's an assumption that a user is going to navigate to a particular page. And so it renders the entire page. So it not only does the TCP TLS dance and grab resources, it actually renders it in a headless tab of some form. And so when a user does navigate to that particular page, they see a seamless transition. They don't even notice the load time because there isn't any. And so from a user experience standpoint, this is the nicest and most seamless process. But of course, it takes much more bandwidth compared to the other two. And so in general, when we look at those three concepts, you have to do a cost-benefit analysis. And this table shows you visually what that looks like. And this is taken from a talk that Yoav Weiss gave at Velocity Conference a couple of years ago, which just looks at the cost-benefit analysis of DNS prefetch, link prefetch, and pre-rendering. And as you can tell, pre-rendering, which is right at the bottom, has an incredibly high cost. But the benefit is also really high because, one, it does take a lot of bandwidth, but from a user perspective, it's really positive because users don't notice that lag. They don't notice anything. And then at the top is the DNS prefetch, which again, the cost is super low because you're only establishing a connection. And the benefit is low as well because users don't really notice the difference in time. It might be milliseconds, if anything. And so there are assumptions that you can make in order to figure out how to prefetch. And there are various things that you see out in the wild. So search engines generally do this. Google doesn't because it has AMP. But I'm going to look at DuckDuckGo because that's different and not Google related. But in general, what search engines do is the assumption is that users will click on links at the top of the page, not on the bottom. And so because of that assumption, it prefetches the resources at the top of the page. So this can be in the form of the first few links or whatever's within the viewport. And then automatically when a user does end up navigating to those, the resources have already been prefetched. So the time to load is much shorter. Similarly, another assumption you can make in terms of how to prefetch is a login flow. So generally with login flows, it's a pretty general and common process where you go from a login screen to a dashboard. And so because there's the assumption that that's generally how users are going to flow from one page to another, in the login itself, you can prefetch resources associated with loading the dashboard. So even if the login is unsuccessful, let's say the header and the footer are the same for the logged in and logged out experience, you can prefetch those ahead of time and then fill the content in as needed once the user has logged in. So that's another way in which we can prefetch resources ahead of time. There's extra steps you can take in order for this to, you can take like user experience into consideration. So those did take user experience into consideration, but this goes a little further. So it looks much deeper into how exactly a user is interacting with the page and then looks into that. So for this, again, we have the same concept of links that are within the viewport that a user sees. So as long as links become visible within the viewport, the links will be prefetched, and then a user is able to navigate there with the prefetch resources already available. So again, it's much faster. The other way in which you can do this is through hover events. So here, if a user hovers over a particular link, the likelihood of them clicking on it is really high. There's also a bit of a lag sometimes between the user hovering and the user clicking. And so within that lag time of them deciding whether or not to click on the link, if you prefetch resources and they do end up clicking, it's almost an instantaneous load. So they don't notice that, which is really nice and is an optimization that we can make. Of course, all of this so far that we've done is fairly speculative. I'm sure there's some assumptions we can make which are fairly intelligent, but those assumptions are speculations because we're just guessing where a user is going to go. We don't necessarily have concrete data in which we can use to make those decisions. And so a better approach would be to predict where a user is going to go, because then you can predictively tell where, based on where a user is going to go, what to prefetch. And because a lot of prefetching requires a lot of bandwidth and requires a lot of time, doing things predictively allows us to save that cost that we're saving a lot of that cost that is associated with any of those things. So a really good example of predicting or how predictions work, I'm going to use a really naive example, is with weather-related data. So when we look at the weather, generally it's really hard to tell what the weather's going to be like tomorrow. But the way that that's done tends to happen in terms of what the weather was like or what it has been like in the past. And that's generally how weather is predicted. So let's say yesterday was a cloudy day. What is the assumption that tomorrow is going to be rainy or cloudy, or what is the weather going to be like tomorrow? So we can look at certain data points. So let's look at a week's worth of data. And with that, we can actually make some predictions as to how the weather will be like following a cloudy day. So following a cloudy day, we have 3 instances of a cloudy day and 1 instance of a rainy day. So I know that 75% of the time, a cloudy day follows a cloudy day, and 25% of the time, a rainy day follows a cloudy day. So this is just basic statistics if you think about it. And then again, you can do the same thing with what days or what kinds of days follow a rainy day. And because our data set is fairly small, we'll go into like more bigger data sets later, but this is purely to demonstrate a concept. If you look at what follows a rainy day, we have 1 data point and we know it's going to be cloudy. So 100% of the time, a rainy day is followed by a cloudy day. Again, that's general statistics and how that works. So we can put this into a transition matrix, which is generally how you visualize this kind of data. So I can look at an overcast day, and if it's an overcast day tomorrow or today, 75% of the time it'll be overcast tomorrow, and 25% of the time it'll be rainy tomorrow. And the same for what follows a rainy day. It's 100% of the time it's overcast. And then we can visualize this if you would prefer something that's a bit more visual, that's not a table. This is similar. So the arrows pointing to itself means that it is the same type of weather following on the same day. So if it's a rainy day follows, it's 0% of the time, so 0 and so on. And so we can actually use this technique in a similar fashion to how users move from one page to another. This is just a data set that I created on my own to show you what I mean. So here I'll rearrange it a little so you see it a bit clearer. So we have 4 instances of an about page and how users move from there. And I can see that from the about page to the menu page, 50% of the time, so there's only 4 data sets, so 2 out of 4 is 50%. So 50% of the time, users move from the about page to the menu page. and 50% of the time users move from about to contact. And I can do the same math for users moving from the menu page to a root page or wherever else. So 50% of the time users move from menu to root and so on. And all of this data is actually available through Google Analytics. So I created that data set purely to demonstrate a concept, but Google Analytics gives us access to this data from a live website, which is really nice. So if you go into the dashboard, you'll see once you go through all the various tabs, you'll see the data associated with what I'm talking about, which is essentially called navigation summary. The dashboard doesn't, in my opinion, the dashboard is not super clear, or at least the language around it is a bit confusing, because when they say previous page and next page, the assumption is that there's a sense of what a current page is. So you assume there are 3 data points, but in reality, there are only 2. They only take so I guess previous is what follows previous is next, and what precedes next is previous. So that's essentially how it works. And to me, that's not very clear. And so I prefer working with raw data because it feels a little clearer to me and I can data munge it however I want. So I'll show you what exactly that data is like when I pull directly from the Google Analytics API. So this is just whatever I copied from the Google Analytics API based on when I queried it. And I want to focus specifically, you get an array of objects. So I'll focus on the dimensions. So dimensions in Google Analytics is just where a user came from and where a user is. So current page, past page. That's what I'm going to call it. Current and previous. So previous page path is root. Current page path is root. As you can tell, this is probably an anomaly because a user may be refreshed or something, because this is not very useful data, but purely to show you what those metrics mean. And then within metrics, you have this concept of values, and values is an array. The first entry is this concept of page views, which is overall how many users viewed the page. And then exits is how many users left the page. So I know that 4 people actually viewed and one person left. And I'll look at a different data point because it's a bit clearer instead of like one that goes from root to root. So we'll look at the second dimension or next dimension. So it goes from root to post. That's a bit clearer because there is a movement that's actually useful versus a user not going anywhere. And so we have the same concept of previous page path and current page path, and then we can make that comparison. So what I'm going to do now is I'm just going to show you all of that data combined together. So previously they were in different pieces and chunks, and you had to compare them from one dimension to another. So I cleaned it up slightly. And again, don't worry about how I cleaned it up because data cleaning is fairly boring. And so what I did is I aggregated it so that you can see all of the associations next to each other. So we're going to assume that in this particular object, the page path is root. And in the next pages array, you see all the possible next pages. So on line 8 all the way to line 21, that's like the array of next pages. So users have gone to posts, about, and contact from the root page. And so what I'm doing to get the total number of next page views is I'm just adding those numbers. So 4 plus 1 plus 1 is 6. And so I can know that the next page views is 6. So 6 users, or 6 altogether people, have gone from root to another page within the application. Ta-da. Okay, so that's how exactly I come to that number. And then the same for exits. So exits counts as an action, like a user action. And so in this particular instance, 0 people exited that particular page. So 0 people went from root to leaving the app completely. And so I want total page views, which is just like total number of actions is what you can think about, is 6 plus 0 is 6. So 6 is the total number of potential actions, or not potential, actual actions that users took from the root page. And so with that number, I can actually do some like statistics. So what I'm doing here is I'm just checking to see what the probability of users going to posts from root is. And so I know 4 users went to posts from root. So 4 out of 6 is 2/3. So I know 2/3 of users go from root to posts. And similarly, I can do the same for about and contact. It's about one out of 6. And so with that, I can do some like basic like sense of what that that is looking like. And then I can use it to figure out how exactly to prefetch. So this, I'm going to, with that sense of how exactly the math behind that statistics works, we're going to look into how I'm going to automate my build. So I'm adding that to my templates. So it's predictive build automation. And for this particular piece, I'm going to be using various tools. So I used Google Analytics. I talked about that. I'm going to be using 11T as my static site generator. And the reason for that is that 11T is super lightweight. There isn't a lot of JavaScript. So from a web performance standpoint, it's really straightforward. Also, piping data and working with data and optimizing things is much easier. And so because of that, I'm working from a baseline. So I'm going to choose 11T. And then I'm going to pipe that into Netlify because that's generally how I run builds when I build applications. So what we'll start with to bring the Google Analytics into our application is that we need to make sure that we are requesting the Google Analytics API properly. And in order to do this, we need to do some OAuth things because Google has very particular ways in which you need to do OAuth. So this particular piece of code that's being highlighted is how exactly that auth is being, I'm creating an instance essentially of an auth client. And then with that auth client, I'm just going to add a query parameter. There's a lot of data in this particular piece of code that I highlighted. But the piece that I want you to focus on is on line 17, which essentially is telling me what the end date is. So I want my data to be relevant as of yesterday until 30 days before that. And that's essentially the length of time my data is valid for. So it's not data forever, it's data that's pretty recent. And so what I'll do at the top is I'm going to do my OAuth dance, which involves like doing that OAuth stuff and then passing in the query parameters and so on. And then line 51 is where I'm aggregating that data. Again, I will not go into detail on data cleaning because it's very boring. But once I clean that, I'm essentially returning all of the aggregate pages. If you're interested in learning about how exactly I did all of this, I wrote a post for Perf Planet's Advent calendar last year. And so feel free to check that out. It goes into painful detail as to how that works. And so I will show you what the data looks like at the end. So assuming everything works and your OAuth works and you have your data, this is what you get. You get an array of objects. So I'll focus specifically on this object that's highlighted. So I'll have an object with various keys and values. Page path is like, we'll assume current page path. I just called it page path. And then next page path is where a user went after the current. So after about, they went to contact. And then I measured the page certainty. So the certainty is just, what is the certainty that they went from one to another? And so that's about 50%. And so with that, I can now pipe it into my templates with 11T. And so with 11T, what it does is it has a concept of nunjuk templates. And so nunjuk templates allow me to inject logic into my template. So base.nunjuks is just a base file that all of the files in 11T uses to build a page. So in this particular instance, in the head, I'm actually adding that particular prefetch link. So prefetch links is a file in 11T, which is where the data munging happens. So I have that as an access, like as an array that I can access. So I can access every entry in it. So I'm iterating with a for loop. And then I'm just checking in this particular instance. This is very 11T specific. I'm just checking that the entry path matches the page URL because I don't want a prefetch link to not match the current page. So if the page that I'm currently building is about, I only want the page path to be about. I don't care about other pages. So assuming those conditionals are met, I can then add my prefetch link. And for this, I'm doing some extra things, as you might notice. The double curly brackets is 11T's or Nunjuk's way of adding essentially interpolation, string interpolation. But I'm piping the entry, which is the particular object, into a filter, which is what 11T calls, it's called filters, called prefetch next URL. And that does some specific logic. And I'll show you exactly what that looks like. So in 11T, there's a concept of filters that allow me to filter data based on, again, more conditionals. So filter prefetch next URL, all it's doing is it's looking at the page certainty, and I'm giving it a threshold. So a threshold is just at what point do I care to prefetch a page? Because prefetching a page that has a 10% accuracy or a 10% likelihood of someone moving isn't very useful. And so for now, I'm going to create a threshold of 0.5, so 50%. So if the next page certainty is about 0.5, then I'm going to actually return that next page path so that it will prefetch that particular resource. So assuming everything works, which I think it will, I'm going to show you a demo in which you'll see it in action. So this is a page that I built in 11T, fairly straightforward. And so I'm going to the menu page. So I know, because I wrote it down, that users go from menu to contact quite frequently. So if I do menu to contact, you'll see in the size over here in the network tab, the prefetch cache. And if I move to another page where like people do go to the blog from contact, you'll see prefetch cache. But if you go to the, let's say, menu, wait, everything is prefetched. Okay, if I go to contact to menu, yes, haha. If you go from contact to menu, it is not prefetched. And so you see the difference between things that are prefetched and things that are not, because general, it's essentially cow paths you're trying to figure out and then optimizing in those particular instances. Cool. So a lot of the work that I've done is actually built off of existing work. So I want to attribute that as much as possible. There's a library called Guest.js that the Google team came up with, and it does just that. It looks at Google Analytics and it does some predictions. A lot of the ways that I've architected my predictions have been based on Guest.js. I rolled my own, particularly because I don't use Webpack, and Guest.js uses Webpack. I think they have some optimizations for not using Webpack, but it's largely built for Webpack. But Guest.js is wonderful. Minko Gichev was the one who spearheaded Guest.js and predictive prefetching, so props to him for that. And you should definitely use it. So all we've done so far is create a rather naive solution. So when I say naive, I mean that our data set is super small. We only are looking at where a user came from right before they're moving to a page. And so what we want to move towards, especially if we're looking at prediction, is something that's a bit more intelligent. And when we think about intelligence, generally what makes something more intelligent is if we have more data points. So if to go back to the metaphor of weather, we had basically a week's worth of weather data, and that's fine, except it would be more interesting if we looked at more pieces or more data points, because we can get more accurate in terms of what to expect. So in the previous example, we looked at what follows a cloudy day immediately, so 1 day ahead. But if we looked at 2 days ahead, let's say, we have a bit more accuracy. We can look at what exactly the weather's like if 2 cloudy days follow back to back. So if 2 cloudy days follow back to back, 50% of the time it's going to be cloudy day and 50% of the time it's going to be rainy. And similarly, we have more data points when we look at 1 extra. So if I look at 3 cloudy days, what's that going to look like? It seems that 100% of the time, if it's cloudy, it's going to be rainy. So again, the more data points you add, the more pseudo-intelligent it becomes, because you get more accuracy with the more data points you work with, which is really nice. So one way you can do this with the way we're working is through cookies. Of course, with GDPR and so on, there's a lot of criticisms around this. But for now, we're just going to use this as a thought experiment. Cookies are one way in which we can track how exactly a user is moving from one page to another. And so with that, we can actually look at, let's assume, not just 2 points of data, but 3 points of data. So a user is moving more than 1 page forward, and that gives us a bit more accuracy around what we want to see. So for now, I can see that if a user is going to root or coming from root, they're eventually going to go to menu. And that's fairly accurate. And similarly, I can also see weirdness as a result of cyclic patterns. And this is not so much a web performance thing, but this allows me to change the overall user experience, whether that be the design of the website or the copy, because the cyclic patterns, sure, they might be edge cases, but they might also indicate strangeness or confusion that users have around your website. And so you can use a lot of the prediction patterns, not just from a performance standpoint, but also to improve your website overall. So that's really nice. And as I mentioned, with cookie-based tracking, something that you really need to take into consideration is GDPR and all the data protection laws, because they're really important to make sure that users are not being tracked against their will. And so that is something that needs to be taken into consideration as much as possible. Another thing I wanted to talk about before ending this is that I talked about build time optimizations. So far, all of our predictions were made and the prefetch links were hard-coded at build time, which is fine. But sometimes if a website is frequently visited, you might want something that's a bit more real-time because the data might change much more frequently than your build cycle, let's say. So for this, we're going to use serverless functions. Again, there is criticism to using this because serverless functions has a cold start. So that can actually, instead of optimizing your site, add extra latency that you're trying to remove from your site altogether. I imagine with edge workers and a lot of development in terms of edge computation, the possibilities of this are endless, and the cold start problem might be mitigated by making the logic live closer to the users and so on. But again, this is purely a thought experiment. And so let's look at the logic we looked at before, and instead of putting it in our build, we're going to put it in a more real-time serverless function. So this is our code from before, which is where we were essentially just doing that request and grabbing things from Google Analytics. So I'm going to go specifically to here. It was a module.export. So we're just essentially running a function and then getting an array. But what we'll do is we'll change it. So serverless functions generally have a handler. So we'll just change that. And then we are just returning the data in the body. And so that's the only change that we're making. And so with this, we can essentially get data from as an endpoint. And I have a demo for this that I hope works. Yes, it works. Okay, cool. So I created an endpoint as a Netlify function. And so with this, I'm just calling that particular function and I get this giant JSON. Well, it's not really giant, but I get a JSON blob of all of my data. So I know from contact to post 0.5% of the time, menu to contact 0.6, and so on. The data is not super accurate because I'm the only one who tested my site. So the data points are small and very different. One thing to note when we look at how to prefetch is also the threshold at which we want to set this. So I glossed over this when I talked about how I wanted to do it. But generally what we want to do is figure out how to put that particular threshold. So 0.5 was my general random metric that I created. But when we're prefetching, we need to think about the user because essentially a lot of prefetching requires bandwidth and takes a lot of data. And so with that, we might want to perhaps check a user's bandwidth before we prefetch in order to intelligently do things. So not only are we predictively checking where a user is going to go, but we want to make sure if that prefetch is actually going to waste resources or actually add benefit. So if someone is on data saver mode, let's say, you might not want to prefetch because someone on data saver mode clearly cares about the bandwidth and data that they're using. And so you want the threshold for your prefetch to be 0, so you're never prefetching. And similarly, if someone's on a slow 2G connection, you might want to prefetch, but you want to increase the threshold to something that's a bit higher potentially, because again, someone on a lower connection might not want the resources wasted on a prefetch. And again, another thing is to note the recommended approach. So to return back to the table I showed you, which is from UI's presentation, just the cost-benefit analysis of using one over the other. So for instance, pre-rendering is an incredibly, it's huge in terms of benefits, but it's also huge in terms of cost. So maybe never do it altogether. And similarly for DNS prefetch, the cost is really low, but the benefit is low as well. So maybe that might be useful in some instances, but not all. All in all, this is to say that when you are building a site, like an open source website, you might want to optimize for who is accessing a website. So let's say you are in the Netherlands or a country where people appreciate their sauces. You might want to show more than one sauce. But if someone is not, let's say in America, they like ketchup and mayo. So you might want to optimize and prefetch only 2 types of sauces because Americans only like 2 types of sauces. And so with that, I conclude my presentation on predictive prefetching. Here are the links to everything. The GitHub repo has all of the code associated with what I talked about, and the slides are on notice as well. Thank you.